Hey everybody, welcome back. This is kind of an exciting section because it's kind of like you've been preparing for it your whole life. We're going to take a look at 6-5 solving radical equations. We're going to do 4 examples, so I kind of broke my paper into fourths. But before we get going too far, we're going to give you a little public service announcement. Here's a PSA for you. Whenever you're working with radical equations, you must check for extraneous solutions. Check for extraneous solutions. Now, an extraneous solution is a solution that seems mathematically sound. It seems like something I could get mathematically, like it, it came from what I've been normally doing to solve an equation. But when you go to plug it back into the original equation, it creates a situation that's just not cool. Remember that you cannot take the square root of a negative number, but you can take the third or the fifth root of a negative number. If you have an even root of a negative number, that's going to be an extraneous solution, or it's going to be an extraneous situation that gives you an extraneous solution. So there's your public service announcement for the day. Let's get busy. Here's example A. So we're going to take 3 times the square root of 2x is equal to 12. That's our first equation. This is obviously a square root because there's no root number on the tail of the radical. So the first thing I'm going to do is move that whole number, that integer that's in front of the radical, divide both sides by 3. Now I have the square root of 2x is equal to 4. 12 divided by 3 was 4. What's going to undo a square root? Squaring both sides. So my next step is to square both sides. On the left, the square and the square root cancel out. I have 2x is equal to 16. I can mentally divide both sides by 2. X is equal to 8. But remember, we always need to check for extraneous solutions. If I plug in this 8, do I have a true statement? Well, this is like 3 times the square root of 16. The square root of 16 is 4, and 3 times 4 is indeed 12. So yep, that checks out. It's all good. I'm going to lock that in as a final answer. Let's take a look at another example. So if you're thinking, oh, that's not too bad, well, good. We've really kind of done those before. But in this next example, I'm going to give you a third root. So we're looking at the third root of 5x plus 2 minus 3 is equal to 0. Third root of 5x plus 2 minus 3 outside of the radical equals 0. Well, first of all, we want to isolate the third root. What would undo a third root would be a third power, so I'm going to raise both sides to the third power. Third root, third power cancels out. I know that 3 to the third power is 27, and then you know what to do from here. Maybe you could even just do this mentally. Before I put a box around that, though, I am going to check to make sure that it's not extraneous, that x equals 5 is not an extraneous solution. So I'm thinking the third root of 5 times 5 plus 2, and then if I subtract that, is it equal to 0? Well, this would be 25 plus 2, which is 27. The third root of that is 3, and then 3 minus 3 is 0. So yep, that checks out as well, not extraneous. So I'm going to put a box around that and lock that in as a final answer. We're doing great on time. Hopefully you're doing great on math. Let's take a look at a third example, letter C. This problem is going to be different because I'm going to have radicals on both sides of the equal sign. 3x plus 15 over here. So as long as you don't have, anything too crazy going on, it looks like a root or radical, equals a radical, a square root equals a square root. I think that the best thing to do with this problem would just be to square both sides. In algebra, as long as you do something to one side and the same thing to the other, it's all good. I have 5x plus 1 because the square and the square root canceled. equals 3x plus 15. Again, because the square and the square root canceled, I'm going to get my letters to the left. I could also say that I moved the smaller of my two variables. And then I'm going to subtract 1 on both sides to get my constants on the other. And 15 minus 1 is 14, making x is equal to 7. I don't know if I should lock that in as an answer just quite yet. We better check for extraneous solutions. So to check for the extraneous business, square root of 5 times 7 plus 1, that would be the square root of 36, which is just 6. Hopefully that's going to be equal to the square root of 3 times 7 plus 15, or in other words, 21 plus 15, which would be 36, whose square root is also 6. And yep, 6 is equal to 6. That checks out. Lock it in. X equals 7 is our final answer. One more, letter D. So if you feel like I'm rushing here, I do feel like I'm kind of going fast. Remember, the beauty of this process is you can stop the video, rewind the video, rewatch the video. The sky is the limit. Letter D has a radical on one side and then no radical on the other side, but instead this binomial, x minus 4. Okay, well, we are going to square both sides, because then at least I don't have this radical anymore. I'll get x plus 2 on the left, but on the right-hand side, I need to expand and FOIL. So remember, when you are squaring something, you are multiplying by itself. Multiply by itself. And then x times x is x squared, minus 4x plus 16. First, outer, inner, last. And then over here I have x plus 2. Oh boy, as I step back and look at this, I see a quadratic equation. So I might end up factoring or using the quadratic formula. Let's see what we have. We want to get the equation set equal to 0, so I'm going to subtract x, and I'm going to subtract 2. Okay, I have 0 equals x squared minus 9x plus 14. Negative 4 and negative 4 is negative 8. Another negative 1 would be negative 9. Okay, can I factor this plain Jane trinomial? What two numbers would multiply to 14 but add up to negative 9? Negative 2 and negative 7. We haven't factored in a while. Hopefully that comes back to you. So then I can rewrite this as x minus 2 and x minus 7. What would my solutions be? Remember, we need to use the zero product property. And my solutions would be just x equals 2 and x equals 7. Again, zero product property. But before I lock either of those in, I need to check for extraneous solutions. So here we go then. To check, let's check x equals 7. That would give me the square root of 7 plus 2 is equal to 7 minus 4. 3 is equal to the square root of 9. Yep, that checks out. And then let's check x equals 2. So the square root of 2 plus 2, is that equal to 2 minus 4? 2 plus 2 is the square root of 4, which is 2. Now 2 minus 4 would be negative 2. Does 2 equal negative 2? Not today. So x equals 2 is extraneous. And then my only answer would be x equals 7. All right, that's a good place to stop. Keep thinking about solving radical equations. This really wasn't too bad, was it? You've been preparing for this your whole life. All right, I'll see you next time.